let's get into some content. First, anybody got questions? And a reminder, I have the Discord open right now. I think it's just mostly me at the moment. But if you have questions, let me know. TAs are good about being in there and answering your questions. But do you have any questions before we get into content? I'm going to turn into lecture mode and just go on autopilot. Yo. What's that? Can you speak up? Oh, yeah, we're on the wrong week. Yeah, we're skipping ahead a little bit. Just a couple weeks. That's better. Hey, all right. I like to think I would have got like halfway through that lecture before somebody was like, wait a minute. So I'm glad you did it on slide one. It was much better that way. So what's up, Cole? What's up, Dragos? All right, no new lecture test today. No new content today either. We're going to reinforce the content we learned over the last two lectures. Monday's lecture, there's a lot of stuff coming at you. Last lecture, we really hammered down references. Today, we want to solidify all that content. We're going to see more classes, more objects, more references, more heap, more stack. We're going to see all that through one big example with quite a few moving pieces. So no new lecture question. This is still lecture task 2. Working with the sale and sale test item classes and passing by reference. And next week lab is the prep lab for project 2. So you almost certainly should be talking about this in lab. I'll remind the TAs during our meeting on Monday. When we're talking about these reference lecture tasks, there's one incorrect solution in AutoLab, which the AutoLab is posted. Some of you didn't see that if you're ready to submit. That really hammers down the references. That's the no OOB percent for going out of business sales, which I have quite a bit of explanation in the document now. I want to make sure everybody knows what's going on with that, so there's quite a bit of explanation in there now. The OOB percent is messing up the references. So when a sale testing item gets a sale, instead of storing a reference to that sale, it's storing a copy of that sale with the same percent off. It's not storing it by reference. It's not doing the references right. So in your testing, you need some way to test that to make sure that the sale testing item is storing references to the sales that it gets. The way to do that, best way to do that, create a sale, store a reference to that sale in a variable, add that sale to a sale testing item, check the price of the sale testing item, make sure everything basic is working the way it's supposed to, and then go to this percent off. I named this percent off for a very specific reason. It's so you can go to that reference of the sale that you stored in the variable and say dot percent off equals and then something else. Change the sale price. So the idea of this is a going out of business sale where there's signs that say everything on the store 10% off. And then you take, in our context here, that sale will be represented in the software system as an object, and that'll have that 10% off sale, and then a reference to that sale will be applied to every item in the store. And then the next day, the manager wakes up and says, all right, it's time to go 20% off, change all the signs, everything now 20% off, huge, going out of business sale. You don't want to go to every item and update that sale again. You're just going to update the reference to that sale, change that to 20%, and you want the price of all the items to automatically update. So when somebody rings up an item, that's now 20% off. So that's the idea behind this OOB, out of business sale. That sale price is going to change after the sale has been attached to the object. So attach the sale to the object, change the percent off, and then check the item price again and make sure it updated with the new sale price. Make sure it went from 10% off to 20% off. So this is where we're really starting to think about references. This is in our code, thinking about what we're seeing in the slides with the heap and stack, making sure you understand that. If you can get that no OOB percent incorrect solution out of there and make sure you're handling references properly in this task, then you're going to have a decent understanding of references. So that's the whole idea of this lecture question. I won't go through the whole question again like I did Wednesday, but I wanted to add that to make sure you know how this relates to the lecture content. It absolutely relates. All right, any questions about that? Project 2? Project 1? I mean, you should really be, I don't want to say that. But Project 1, in terms of lecture, at least Project 1's in our rearview mirror. So hopefully you're wrapping that up. Remember, the checkpoint is next Friday. I had some students panicked that they feel like they're behind if they're still working on like lecture tasks 3 or 4. It's not the time to panic quite yet. Just relax, work on it, get a little bit more done every day and get it done before that checkpoint. But I do have to caution you, if you get too far behind, like the deadlines are a little loose, and as long as you show effort, you'll get that 1 week extension after the checkpoint. If you don't know what I'm talking about, reread the syllabus, rewatch lecture 1. I don't want to go into all that right now. But if you need that extension and use that extension, you might be finishing Project 1 at the end of Project 2's lecture content. Once you start slipping behind in this class like that, it's really hard to get caught back up. The deadlines are a little bit loose in that they should be, homework 1 should be due today, really. But since you have to complete all 6 of these lecture tasks or fail the class, I can't have it just flat out due right now, this Friday. So keep that in mind that if you're using up all that time, you're falling behind pretty quick. Just because I don't want to fail you right now doesn't mean that you're in good shape if you fall behind. Homework 2 is going to be quite a bit more difficult than homework 1, so make sure you're getting that start on that while we're talking about homework 2 during lecture. Be working on that during that time. But that's all. I don't want to dwell on that too much. That's all I want to say about that. You all know you're all going to make your own decisions anyway, no matter what I say. And honestly, it's the students who aren't here in the room right now that need to hear this the most, so I don't want to spend too much time on it. All right, so let's talk about another memory example. This is the example we're going to talk about all lecture. We're going to spend a lot of time dissecting every piece of what's going on in this program. And if there's time at the end, we're going to go into the debugger and run it again and show it in the debugger so you can see how it's going to look if you wanted to see the same thing that we see in the slides today on your own in IntelliJ. So you can generate as many examples like this as you want, and you can trace through a program and see what's happening on the stack and heap in the debugger. And I'm going to hammer that home. Those of you who visit me in office hours, if your question wasn't really a simple answer, you know that I'm going to jump to the debugger. I'm going to jump to your testing, and then I'm going to jump to the debugger. And the TAs are probably doing something similar as well. If you learn how to use that debugger, it's going to save you hours and hours and hours of time if you learn how to use that quickly. All right, enough of that. Let's get into this example. So we have a simulation of a very simple, basic RPG elements. If you're into that thing, I am personally. So we have a main method that's going to create characters in a party and have them fight some battles, gain some experience, and keep track of the battles won. So we have a few classes here. I want to highlight the classes on this slide, and then we'll go through the rest line by line. But we have one class. So just a reminder, a class is a template that's used to create objects. So this party character class, it doesn't take any parameters in its constructor, so we get no extra state variables from the constructor. But we do have 2 state variables that will be initialized both to 0, battles won and experience points, both as ints. So whenever I create a new party character, I'm going to get 2 copies of these 2 variables, battles won and experience points, and they'll be initialized to 0 and attached to that object as its state. And then no behavior in the party character class. Then we have a class party, which is going to be 2 characters, just so it fits better on the slide. We could have more, of course. But 2 characters that are initialized through the constructor as vals, so these cannot change. The references stored in these 2 values cannot change. So 2 values that will be part of the state variables, or state values, I suppose, of this party, character 1 and character 2, both of type party character. So these will be references of objects of this type that we created. Remember, when we create a class, we're creating a brand new type that we can use anywhere in our programs. We can use this party character type, once it's defined by this class, as a parameter, as a variable. We can create objects of that type. We can pass them as arguments. We can do anything we can do with other types, like int, double, string, list, map. Party character is a new type that's on the same level as those other types that we've been using that come with Scala. Same with party, we're defining a new type. We're taking 2 party characters as parameters in the constructor, and initializing a 3rd state variable, battles1, which is going to keep track of how many battles the party as a whole has won. And then we do have a little behavior here, this win battle, and I'll save the details for when we're stepping through this line by line. Yeah, I can't wait for lab with the test cases for point of sale as well. The test cases for point of sale do get interesting. I don't know. I don't know. Maybe most of you don't agree, but I had fun writing the test cases for that as well. So I'm with you there, Cole. As long as you're not being sarcastic, then screw you, Cole. So I assume you weren't being sarcastic. I shouldn't have said that. So we're going to start our program at the main method. And we're going to get the stack allocated for us. We have some memory for the stack. And we're going to put our command line arguments. Those are going to be on the stack for us, the very first thing that we have on the stack. We've seen that plenty of times. We're also going to create 2 variables, put them on the stack. We've seen this plenty of times. Create 2 variables, mob XP and boss XP. How much XP are we going to gain from destroying just a regular mob? And how much XP are we going to gain from defeating a boss? And we're going to get 20 XP and 100 XP respectively. So that we've seen before, adding variables to the stack. So let's get to, well, the next thing we've seen before too, but this we've only seen once, so let's reinforce this a bit. We've been seeing the stack since learning Objective 1, way back then, last week. So let's get to some LO2 stuff. We're going to create a new party character. We're going to use the keyword new, which whenever you see that keyword new, you got to be thinking, okay, this is going to create a new object on the heap at a brand new location in memory that we haven't used before. So when I see new, okay, we're asking for more heap space and getting more heap space in our program at some location. We don't care where. This number is arbitrary, but at some location in memory, and we're going to have a reference to that location. What I'm creating a new thing of is party character, so I got to look up that type. Okay, the type party character is going to need space for 2 integers. So when I ask for heap space, I got to ask, or this is all internal in Scala and the JVM and the operating system, but we're going to need memory for 2 ints. So the space that we get on the heap is going to be large enough to store those 2 ints and whatever overhead we need to store this object. Something that says this is an object of type party character might be helpful, but at the very least, the details we need to be concerned about, space for these 2 variables, which will be on the heap. So these ints, I've said before that ints will be stored on the stack, but that's only true if they're declared in our current stack. I think of the best way to word that. If they're declared as a value inside of the current method call, when they're attached to the state of an object, since that object's in the heap, those ints will also be in the heap. So ints don't always go on the stack, but if they're used directly, they're going to go on the stack. If they're not part of an object, that we're creating with the keyword new, then they're going to go on the stack. But if they're part of an object, they're going on the heap as part of the state of that object, because that object is on the heap. So we create a new party character, declare these 2 variables, initialize them both to 0, and then on the stack, we're creating this hero variable, well, value in this case. I'll often call values variables just to keep things simpler as I'm talking, but technically a value. But this variable hero is going to get a reference to this object on the heap. So when we create that object, the only thing we store on the stack is a reference to that object. That's the only thing hero gets. Hero doesn't know anything about this object that it refers to. All it knows is this reference, which is the instructions, where can we find this on the heap? That's the only thing hero knows, that variable. Now let's get to some pass by reference. So we have this method call, And we're assuming that this method is defined in the same object as the main method for what it's worth. I got that question before, so I like to specify it. And you can also go to the code in the examples repo if you have any questions like that, how exactly this is structured. Because I have to chop it up a bit to fit it on a slide like this. We're going to fill the slide with all kinds of information. So I need all the room I could get. So we're calling win battle with arguments hero and mob XP. So to call this method, we have to resolve the expressions that are used as the arguments, which are hero. So we're going to look for that on the stack. This stack frame wouldn't be here yet. This is what we're creating. We're going to look for it on the stack, and we find it right here. Hero, that has the reference at 428. We're going to look up mob XP. We find that right here as the value 20. We're going to create a new stack frame for this method call, and we're going to create the parameters, character, and XP, put them both on the stack inside the stack frame, and assign them the values of the arguments. Now for this method, we have two different types of arguments being passed. One of them is a reference to an object that's on the heap, which is going to be passed by reference. Again, technically passed by value, but the value that's being passed is a reference. We're giving a reference to that object, to this stack frame, to that parameter named character. But XP, this is an int. This is what I'm calling our primitive values. When we get to next week, we'll see that by primitive, I mean objects that inherit the, I shouldn't even mention this, but inherit the anyval class when we talk about inheritance. Those are going to be passed by value. So this XP variable is going to get the value stored in mob XP, which is the integer 20. So this XP inside this stack frame has zero relation to this mob XP outside the frame, besides the fact that it got a copy of its value from that variable. Other than that, they have no relation. Anything I do to XP, any changes or anything, will not affect mob XP the same way we can when we have a reference to an object. We can't make a change to mob XP from inside of this stack frame because this was passed by value. But this character got a reference. Since this got a reference, we can make changes. So there's a very different behavior. With our understanding of stack and heap, we can see this. There's a very different behavior than when we call a method and pass it something like an int, a double, a char, a boolean, or if we call it with a list, a map, a party character, a player, like we saw the example on Monday. Any object any class that we've created, any objects of those types that we created, these are handled very differently because one of them is passed by reference and one of them is passed by value. So these ints, doubles, chars, longs, floats, booleans, these are all passed by value and they can't be changed. Everything else is passed by reference, everything else. So since this hero was passed by reference, when we start this stack frame and start doing our computation, and we start using this dot operator, which says, hey, I know character, variable character, I know you store a reference. I really don't care about your reference at all. I care about the object you refer to, that your reference refers to. So we use the dot operator to say, I don't want to be on the stack anymore. I want to follow your reference, go over to heap space, and find the object to which you refer. So the dot is going to say, this at 428, take me there. So once we see that dot operator, once we hit that, we're going to be over in heap space now, in heap memory. Now that we're in heap memory, we're going to access specifically this. So when we call this method, I'll back up a bit, but I'll go through it a little bit faster, just in the interest of time. So when we call win battle, we have two different, just because I don't remember how far back to go. Oh, what I was saying, the mic was dead when I said it, but the mic pack had enough juice to actually display dead battery on the display. I just thought that was cute, so I thought I'd share. So when we call this method, we get two variables on the stack from the two parameters, character and XP. And one of these is passed by reference and one is passed by value. So we have very different behavior between this int and this party character. So our ints, our doubles, our longs, our floats, our booleans, all of these, which I call the primitive values, which are values that extend any val, which we'll talk about next week, those are passed by value, which means we got this value 20. When we looked up mobxp, we took its value and gave that value a copy of that value to xp. So we have a copy of the value 20, and any changes we want to make using xp, anything we do to that, will not affect mobxp in the main stack frame. They're not connected. Mobxp just gave a copy of its value to that xp variable. But hero and character, these are inherently linked because they have references to the same object. So character got a reference. We call this passed by reference. Technically, it's passed by value, but the value that's being passed is a reference. So these variables refer to the same object. So this character is passed by reference and can make changes to this hero outside the class. So that's important to remember that those ints, doubles, booleans, floats, chars, longs, those behave very differently than everything else in Scala. Everything else in Scala is going to be passed by reference and will be able to make changes to the changes on the heap. Everything else, those ones I listed are passed by value and can't make changes. So this is why this heap and stack stuff, when we understand this is where it really matters when we're coding, is because we have to be aware of what's being passed by value and what's being passed by reference. So we know what methods could potentially change my heap, and maybe I want to myself change the heap. Maybe you want to write a method that does change the heap. We can do that, but we have to be aware of what's being passed by reference and what's being passed by value. So after that method call, stack frame ends, all those, the parameters are destroyed. Mobxp, nothing can possibly happen to that. But hero is referring to at 428. At 428 has those changes applied. So even though that method call is over, the stack frame's gone, the parameters are gone, if we declared any local variables inside that method call, those would all be gone, but that change to the heap persists. Can you put a class in the parameter? So passed by reference, like character, since it's a class that we created, it's not one of those int, long, double, float, char, or boolean. It's not one of those, so it's going to be passed by reference. So the value stored in character is a reference, which refers to an object on the heap, which is the same object referred to by this hero object, this hero variable. Passed by value is what happened here. We got a value 20. XP doesn't refer to anything, any other memory location. It just straight up has the value 20, and that's it. So it can't affect anything outside of just, here's my value 20. That's all it can do. That's passed by value. All right, so that stack frame's gone, but the changes persist. We changed the heap. All right, now let's get into some juicy stuff here. We're going to hit this big line. A whole bunch of stuff's going on. Let's talk about what's happening here. It's the same stuff we've been seeing, just a little more complex. So hopefully by now it's starting to get hammered down, understanding this stuff. So we have an assignment. We're going to create a new party, and new party, we're going to have to resolve the arguments. So this is where we're going to have to start. You can think of your order of operations with parentheses and stuff. We have to start resolving things inside these parentheses. So hero first. When we want to create a new party, we're going to have to resolve hero. Well, that's easy. We just did that in the last slide. Hero resolves to at 428, the object that's already on the heap. Done. The next one, new party character. We're going to create a new object. New returns a reference to the object that's created, and then we're going to use that reference as the second argument of this constructor call. That sentence I spat out right there is a good vocab test. If you can follow all the vocab in there, you're doing awesome. So this constructor call is going to do the same thing that it did when we created this new character. This new party character, we're going to go to the constructor, nothing to do there. We're going to create these two variables, allocate space on the heap for those two variables, and then return a reference to that heap space that's been created, that's been allocated. So this at 272, again, these numbers, I'm just making these up. I just pick random numbers. When you run your programs, you're going to see randomish numbers as well. They might mean a lot to the machine. I don't know. I don't really care that much. I just want to know that we do have references to locations in memory. In 220, you'll care a lot more about the lower level details. So I got heap space at 272. So this resolves to the reference at 272. Now I'm not storing that reference anywhere on the stack. We're never going to see that reference on the stack. I shouldn't say never, because one of these method calls later, we will see it temporarily on the stack. But I'm not storing that on the stack right now. I'm just taking that reference this call resolved to, and stuffing it right in the constructor call of this party class. So now party, when its constructor is being called, it has val character 1 type party class equals at 428. Val character 2 of type party class equals at 272. It's going to get those two references and store those references in its state variables. So when we create this party class and then initialize battles 1 to 0. So in the heap space, in this party class, or party object, we're going to store references to these two party characters. So we can find those party characters, and an int battles 1 of 0. There's win battle and win battle over here, which we're about to call the other win battle. We saw the first one. We're about to see the next one. So this is the state of our stack and heap. If you had a quiz where there was a highlighted line like right here, this is what you would draw for your answer. For LO2, you're going to get that same style of question that you have for LO1. For those of you, I know there's still a few labs that haven't had their quiz yet. They're still having them later today. For those of you who have, and for those of you who think about this when you take your quiz, or don't focus on the quiz, you're going to get the same style of question for LO2, the LO2 quiz. You're going to get code that looks like this, at least for the first question. You're going to get code that looks similar to this. You're going to have a highlighted line, and instead of just asking about the stack, we're going to ask about the stack and heap. We're going to say, tell me about the stack and heap. So if this was your highlighted line, this is the information that you need to give on your quiz. I have 3 objects on the heap. You can give them random at 1, at 2, at 3, whatever. Here's all their state variables. Here's what's going on the stack. Here's which variables store which references, and give us all that information in the quiz. So let's keep going. We have another method call here, party.winBattle. So now we're calling the other winBattle method that's called through the party class. So we're saying party dot, so party, follow your reference to at 596, which is an object of type party, and call your winBattle method. We have an object of type party, so we're going to go to the party type and look for a method named winBattle, which luckily we find one. We find one, and we give it the argument boss XP, which resolves to 100. So we have XP equals 100. So we create a new stack frame, create the parameter XP, set it equal to the argument, which resolved to 100. And we also, and this is the first time we're seeing this one, since we're calling a method from an object, we also have, it's the first time we're seeing it visually anyway, you know this concept. We have a reference to the calling object in the keyword this. So on the stack, we have the keyword this, which refers to the object from which this was called. So whatever was before the party at 596, that's what's going to be this. That's the calling object. So this is a reference to the calling object. That's what we mean by that. We mean in that stack frame, whatever object was used to create that stack frame, this is going to be a reference to that object. Technically, when we had this method call, we also had this. We just weren't concerned with what it was. I probably called it like RPG main or whatever the object is where this main method lives. We do have that reference. We're just not really interested in it. Now we're really interested in it because this refers to one of our objects. That's an object we created that we care deeply about. We care about what happens to that object. If the state of that object changes, we are interested in that, and it's going to change the behavior of our program. So we want to know about that. So we're concerned about this, at this case, and it's the calling object. Quick side note, we could also do this dot battle win battle. The context is the calling object, which is the object containing the main method there. But those are details we don't really need to be concerned with. So I don't want to spend too much time talking about that. So let's go through this method. The first thing we do, we access this. I do want to cap that one off though. If you omit this, if you don't use the keyword this, it will implicitly be there. So if I just did battles1 plus equals 1, it will have the same effect, but for clarity, it's helpful to always add this dot to be very clear about what you mean when you're accessing the state of the object. Make it very clear to anyone reading the code. This dot battles1, you know you're modifying a state variable. If you do battles1 plus equals 1, it takes a second to figure out what's going on there. If it's a very large convoluted class, it can take a long time for someone reading the code to figure out what's going on. This dot, make it explicit. So this dot battles1 plus equals 1. So we're going to go to this, look up the reference on the stack. We find at 596, follow that to the heap. We find an object of type party. We're going to access its battles1 state variable and increment it by 1. And we're going to do the same thing for all 4 of these. I'm not going through all 4 of them separately on the slides, but I want to talk about each one. Not each one, they're all repetitive. We can follow multiple references in the same line. So this, at 596, dot, follow that reference to the object that it refers to, dot, this dot, character 1. So access the character 1 variable, state variable of that party class, dot, follow the reference, at 428, so follow that to a location in the heap. And now that we're at this location in the heap, so each time we hit a dot, we're going to a new location in the heap, a new object on the heap. And then access its battles1 and increment it by 1. So go to its battles1 and increment it by 1. So even though we're inside a method call, inside a stack frame, doing this dot character 1 dot battles1, what we actually changed was the same object referred to by hero in our main method. So this hero, through this method call, through following a few references, this hero actually incremented its battles1 by 1 because it refers to the same object that was modified through that method call. Same thing with character 2. This, follow the reference, dot character 2, dot follow the reference, this one, dot battles1, increment. Same thing with XP, character 1. This, dot character 1, dot battles1, increment. This, dot character 2, dot experience points, increment. Did I not actually increment that? Oh, that was boss XP. I'm looking for a 20. And then they both get their XP. Do the same thing with XP, get their 100 XP for beating that boss. We're going to say all party members get all the full XP. We're not going to divide it amongst party members. So follow the references. Every time you see a dot, you're following a reference. You're taking a reference and going to its object on the heap. So again, stack frame's gone, but we called that method for its side effects. That method had some effect. It returned unit, and the stack frame's gone, but we called it. It had side effects because it changed the state of memory of the program Therefore, it's going to change the behavior of the program because it made those changes on the heap. Then we can also access the values. So like on the stack, let's go through character one quick. We'll call this party dot character one at 428. And then mob XP, we're going to call this win battle with that character in XP and increment character one. This is the same exact effect as when we called win battle of hero mob XP. We're accessing the same reference through the party because party.character1 is storing the same reference as hero is. But the next one, this party character, we don't even have a reference to this one on the stack. We can't access this thing directly, but we can access it through the party object. So this party object does have a reference to that character. So if we want to reference this character, if we want to access that, we can do party dot follow the reference and then character 2 and get that reference of that character we created. So even though we didn't store a reference to that character on the stack anywhere, we did give that reference to the party object that we created. And then through that party object, we can access that reference and still modify this character on the heap individually without calling like win battles through the party class. So we'll give that at 272 on the stack, so it does get on the stack temporarily right here in the character object inside the win battle stack frame, and then increment its experience points by 20 and battles 1 by 1. Yeah, I just chose random numbers for the heap. This 428, 272, 596, completely random. I just made up these numbers. They have no inherent meaning. The only meaning that they have is like this at 270, this at 428. What this tells me is that this hero refers to this object because the at 428 is matched, and also this variable refers to the same object. So we don't really care about what the value of those numbers are. They're just nominal. But we do care if two variables refer to the same object. That's something we can see and identify, and that gives us some information. Likewise, if they're different, we know that these two variables refer to different objects because those numbers are different. So when we're running the debugger, which we're about to head back to, and all of our memory is gone at the end of the program, the end of the main stack frame. So when we go into the debugger, I'm looking at it like I'm in there. Yeah, RPG main is what I called it. When we go into the debugger, we're going to put a breakpoint right at the start of the main. We're going to run this in the debugger. Actually, let's jump ahead a bit. Let's just jump ahead here so we have some stuff on the stack. We can see that hero, we got 800. Again, it's just a random number. We don't really care what that number is. But we can see that it's 800 and then look at character 1, and we better be able to verify that character 1 is a reference to the same object as hero. So I know their battles 1 and experience points will be identical at any point in the program. No matter what's happening in the program, those state variables are going to be identical because they are in fact the same exact state variables. These aren't two separate objects. These are the same object, and any change made to one of them is going to be made on both of them because there's only one object referred to by both hero and party.character1. But character 2, this number is different, so I know that that's going to refer to a different object, and its state variables can be different. Let's get into one of these method calls. We can see we have 2 frames on the stack. So let me go to this one's more interesting. So debugger tip, if you click this go button, this resume button, it'll resume execution until it hits another breakpoint. So I set 2 breakpoints there, removed the first one, hit resume, and then just jumped up to the next one to get to where I wanted to be in the program. So inside this win battle method that's inside the party class, I can see I have a reference to the party at 801. I have this at 802. I restarted the program, and we just happen to get different numbers. Again, we don't care what the values of those numbers are. We just care these values are different, so I know these are two different objects on the heap. That's what we're concerned about. But if I go to, and this is a reference to a party object at 801. So if I go back to the main stack frame, and I look at the party class, the party variable, that's going to be a reference to a party at 801, because this is a reference to that calling object. And we can see main sitting right here waiting for this stack frame, this method call to resolve that stack frame to end so it can resume its business. Party.winBattle is what we're calling right here. Party was at 801. So inside win battle, this is going to be that party at 801. And it's going to have all of the same stuff as we see in the party class in the main method. And again, we can see hero and party.character1 referring to the same object. Inside win battle, party this.character1 referring to the same object, because this is the same party object in this as it is in party in the main method. Okay, so how are we feeling about that? Is this starting to sink in a bit? I know Monday I could just kind of see that I was losing you all. Are things starting to come around here? Classes, objects, references, heap? Is this starting to make more sense? See some nodding. Feeling good. Good. All right. Have a great weekend. See you Monday.